I cut up onions yesterday and my hands just like reek of onions still. Well, because I didn't want to have them whole. That is possibly the dumbest thing anyone has asked me today. Okay. So guys, we're going to look at something called the Pythagorean identity. You guys have used Pythagoras' theorem to find the unknown side of a right angle triangle. We can actually end up using Pythagoras to simplify complicated equations. So recall that the x of a triangle. So if I'm on my unit circle, guys, the x length or the x coordinate is given by cos. So cos of my angle is equal to whatever my x coordinate is. The y coordinate is just sine of my angle. So for instance, if I was sine of pi on 6, what would my y coordinate be? Sine of pi on 6, what would my y coordinate be? Not a trick question.
Pi on 6.
2. 3 on 30. Sine 3 on 30. Sine 30.
Sine you go down.
Mm-hmm.
1/2. 1/2. What would cos of pi on 6 be?
Root 3 on 2.
Root 3 on 2. So just by knowing the angle, we know the values of the x and the y. Okay?
Thanks.
The one page after the last one we're on. Okay? We know from Pythagoras the hypotenuse squared has to equal a squared plus b squared, where a and b are your two short sides. We can use that to form the Pythagorean identity. I'm just going to show you over here, guys. So we know that 1 squared has to equal to that x squared value plus the y squared value. Do you agree that that is Pythagoras' theorem for that triangle on the left? Let me... Yeah, let's do one let's do one as a for instance. So I also know that x squared is given by cos of my angle. Y squared is sine of my angle. Have I changed the value of that equation from the first to the second line, guys? No? Does someone want to give me a known angle? Like, so, 30? Okay, let's put in pi on 6 as our angle. 1 squared equals cos of pi on 6 squared plus sine of pi on 6 squared. And we said before, what is cos pi on 6 equal to? Root 3 on 2, I think I heard someone say. What was sine pi on 6 equal to? 1/2. Okay, when I square a fraction, guys, what do I do? Where do I do the squared? Top and bottom. What's the square root of 3 squared? 3. The 3 squared would be 9, but we're looking at the square root of 3, so that would just be 3. What's 2 squared? What's 1 squared? What's 2 squared? And by the way, 1 squared is just 1, right? What's 3/4 plus 1/4? 4/4 or 1.
Wait, how do you do that?
If you have 3/4 of a pie and I got 1/4 of a pie, between the two of us, we've got 4/4 of a pie or 1 whole.
So we just made up that angle. So
We just did it as a for instance, but this relationship will be true no matter what angle there is.
so 6 has 30 degrees. Where did that 30 degrees? Where did we say that?
We just chose it as an example. We could do the same thing with 45 or 60 or even 1 or 0 or 90 degrees or 0. They don't work. We could put in 10 pi on 8 if we wanted to. They don't work. Okay. The point is, if you square, cos squared plus sine squared is always going to equal to 1. That's my point. So if we have a look over here in the red, so if we start with Pythag, substitute values from the unit circle, we know that hypotenuse squared equals a squared plus b squared, 1 squared equals cos squared plus sine squared, because remember, one side of our triangle is cos theta, the other side is sine theta. So cos x, sine x. And that is going to be true no matter the angle, that relationship. So like I said, we did 30 degrees as an example, but it would work for anything. We can also rearrange that to be cos x squared equals 1 minus sine x, or sine x squared equals 1 minus cos x. Same thing. Let's simplify some complicated equations, guys. So look at this first one. 3 sine squared plus 3 cos squared. Any thoughts? Oh, by the way, I should point that out. If you see up here, I put my cos in a set of brackets and squared outside of that. Down here, the squared is in between the sine and the angle. That's just another way of saying the same thing. So you ever see a squared? If I wrote this, for instance, what is being squared there? Just the theta. If you write it as sine squared theta, the entire thing is being squared. So they just put it in front just to make sure you're not getting distracted or confused by the theta there. Does anyone have any thoughts? How could I rearrange this so I can simplify it further?
Add the 3s.
We can't add the 3s because they've got different coefficients. So you can only add, imagine if that was x and y. Like if you said 3x plus 3y, we couldn't add them. But can you see that this looks kind of similar to our regular bit here? See that bit looks quite similar to that. What's different about it? Got a 3. Can we get rid of the 3 in any way? Well, there's not an equation here, so I can't just divide by 3. Yeah, we can factorize out the 3, that's right. So that would just be equal to 3 bracket. So we've just taken a common factor of 3, chucked it in front of a set of brackets. Inside the bracket, we have sine squared theta plus cos squared theta. What's that equal to? 1.
But what happened to the other 3? You only put 1 3 in front.
Yeah, because I'd taken a factor from both of them out. If I expanded that bracket, I'd have to do it to the sine and to the cos. So I've factorized out. So I've taken a factor of 3 from each of those terms. Inside the bracket, using Pythagorean identity, that's just equal to 1. So that big ugly equation simplifies down to 3. It's 3 times 1. Questions, comments, concerns? Okay. Would anyone like to suggest, maybe Alyssa, what we'll do on this next one? No. Can you see a similar trend to the last one, Elizabeth? What would we do? Yeah. Yeah, what if you, okay, I'm pulling out a factor of 6 out the front. When you factorize 6 away from 6, what's left over? 1. Because it's what do you multiply by 6 to get 6? 1. Then when I factorize 6 from negative sine squared theta, you're just left with the sine squared. or the negative sine squared. Now for this one, what does 1 minus sine squared theta equal? Someone say 0.
1 minus 1. Does that not equal 1 sine?
Because what equals 1 is cos squared plus sine squared. But if we have a look at these ones down here, 1 minus sine is cos squared. So I'm just going to put it in brackets here. 1 minus sine squared theta equals cos squared theta, which gives me 6 cos squared theta. Now, is that as simplified as the first one?
How do you change sine to cos?
So our Pythagorean identity is 1 equals cos squared plus sine squared. So you can rearrange that just by either minusing sine or cos from one side. And you can see that gave us these two rules here. Cos is equal to 1 minus sine, squared, obviously, and sine is equal to 1 minus cos. And in here, we had 1 minus sine squared. So 1 minus sine squared is just the same thing as cos squared from those identities above. Can we do any more simplification of that one? Is it more simple than it started? Yes, it is. And that's all we can do. Go get it as simple as we can. Okay. This third one's a tricky one. Thoughts? How we might go about doing this one? Put sine out the front, cos out the front. So do we agree there's a common factor of cos in all of our terms there? Yep, so say equals cos theta, bracket. What's left over from cos cubed when you get cos theta? Cos squared. Cos squared theta. What's left in this second term? Sine squared theta. Is there anything we can cancel from there or substitute or anything like that? Yeah. Cos squared plus sine squared is just equal to 1. So our final answer is cos theta. Now, once again, guys, that's not, like, we haven't simplified it as much as the first one, but it's definitely much simpler than it was. There's all sorts of squares and cubes going on in the first one. We've managed to simplify it down to something quite simple. Questions, comments, concerns, quibbles, conniptions, conundrums, clouds. Anyone seen any nice clouds lately?
That's everyone.
Yeah.